¿Qué tal? Buenos días a todos.
Good afternoon, everyone. We're ready to start. Welcome to the first session of CyberCamp 2018. It's such a pleasure meeting here in Malaga. Many of you don't originally come from Malaga, but some of you from afar. I also want to greet people who are watching us and following what we're doing on streaming. Some of them just outside here, some of them whatever. And we are here ready to start to hear from Paco, Francisco José Ramírez Lopez, who's a pen tester. And let me just remind you before we start and encourage you to share what we're doing here on Twitter. We've got the CyberCamp 1818 hashtag. You can say also there, use CyberCamp ES and INCIBE. So we're ready to hear from Paco. He's here to tell us how to use network knowledge reversing Android for pen testing. He's an IT engineer by the University of Seville. He's an expert in cybersecurity, and right now he's preparing his PhD dissertation, mostly focusing on IoT. So, Paco, the floor is all yours. You've got 2 hours ahead of you. Thank you very much for coming and attending my workshop. And I want to thank CyberCamp, the organizers, logically, for allowing me to be here. Well, this is a pretty striking title. We're here to talk about communications on mobile devices and IoT. I'm going to tell you about owasp and owasp mobile. I will also tell you something about SSL Bypass and Communications, so that we have that basic knowledge before we start. As such, we will see how the SSL communications bypass can be done, both for the web use or mobile phone use or whatever device. And then the following step, we'll see setting different mobile configurations for the bypass to be done. We will see countermeasures, for instance, SSL pinning, which you can do through admin access or not. Well, we will see that that's the easiest way, but then we will see more complex ways to go around that. And then we will see that all this knowledge for Android, for iOS, that can also be used for IoT devices. Is the same concept at the end of the day. It's just using devices that are connected to the internet. So, and then working online. So this is my disclaimer saying that we will be working on controlled environments. And what I'm going to tell you about during my workshop, well, I've got that information from blogs, from reliable sources. For those of you who don't know me, this is me up on the screen. My name is Paco Ramírez. I work for Innotec in Madrid. I'm cyber security consultant. I'm a pen tester, and I've been working for 4 years in security issues, mostly connected with hacking. I'm an IT engineer. I have done a master's degree on security, and I'm now doing my PhD on smart applications. I'm an honorary professor at the University of Seville, And just as a reminder that I want to tell you that we are doing the OWASP chapter in Civil, where we organize presentations and meetings on security. Here we can see a list of the certificates that I've been covering during my professional career. So let's start with our OWASP Mobile. I don't know if you're familiar with OWASP. For those of you who are not familiar with it, I'm going to tell you some basic information so that you know how it can be used in auditing, for instance. OWASP started as a community working on a project to analyze web applications. And what can we see on OWASP? OWASP gives us information about well-known vulnerabilities on web services. And we have a top 10 for the best-known units, which is reviewed and updated every 4 years. Here we have information on the results for 2013 and 2017 with the top 10 vulnerabilities, best-known vulnerabilities worldwide. What else can OWASP contribute? Well, many of us here work on security, or maybe we want to audit an application. Well, we have this guide, some guidelines to do different controls on a web application to make it more secure. It tells us how to go one control at a time, giving you information about the controls involved. And say, for instance, the first control, footprinting. Well, what information can I get about a server? For instance, on publications, information on the domain. Well, the OWASP tells us how to test every control. It tells us about how you have a white box, gray box, black box auditing options and how the tests can be modified depending on the type of audit. I'm here to tell you mostly about mobile possibilities and IoT possibilities. I'm more of an expert on the mobile side of things. And there was a recent project which is OWASP, just like it was applied for the internet, for the web, but from mobile applications. Here we can see some of the information that has been coming up for mobile applications recently. And during my workshop, we will see a bit like the testing guide for the web, well, something similar, but for mobile environments. In mobile environments, it very much depends on the app that we're going to be auditing or securing for certain controls. Then you have different levels.
¿Qué es de información de dónde está?
So if we are discussing what ATMs are that we see on Google, maybe there are some controls that I need to use that are a bit complex for the application. And then, what about a health application? If these data are critical, we need to follow tighter controls. That's why OWASP Mobile has the following layers, 3 of them. One is standard security, second level would be in-depth security, and another one that is reverse engineering. Based on the kind of app we want to audit, we need controls from one block or the other. We have architecture, storage, cryptography, and many other types. Last one is reverse engineering, and then on the guideline there are 2 columns there. And depending on the one that will be auditing, we will have a first column, the first control, the first audit, and the other ones, the rest of the audits. So what can we highlight of all this of this whole guideline? I feel there's 5 of them that are worth pinpointing or that we should take into account when running our tests. First one, SSL Pinning. That is masking code. That's the measure I have for the source code that is on our app. And through reverse engineering, someone could remove it. But if I change it or modify it, so when someone gets the code, finds it is not legible, I make their attack a bit more difficult. They cannot see those features in my app. That's why I refer to obfuscated code here. So all that code coming into my app comes out in a different way. And how is that? Instead of following, I don't know, sensitive code encryption, I say ABC or 1, 2, 3. So it becomes more complicated when reading it. And then what about mobile apps where we have the root detection as well? If you have someone having access as an admin into our device, if that information, for example, the Samba part of the device, since they have admin permits, they can have access. So if I use some controls to make sure that they don't have access to that sensitive information on Samba, I am securing my app. Then we have the depuration model, because if I manage to depurate or clean an app and see what it does, if I can debug it, I can modify it so it does something else that should not be done. That's why it is run. Here you have an example where you implement both. It is simple on Android. You have the source code there, and you just ask, can you debug it? Is it the debugging activated? Do I have access to the sandbox? So that's regarding the admin permits. Then changes in the source code, or what I call anti-tampering. Same as with ATMs or TPVs that you use for payment. If with any device you open it up, any box, you open it up, there's a system in there, so the firmware inside gets deleted. So anyone that's trying to tamper with the ATM, they will not have access to the source code. Something similar on mobile phones, so it's the same concept, but not exactly identical. If I check the signature on the app, because I use my certificate for signature, if the certificate I have is not the one I have, so the apps and mine are not the same, I close it down. That means that someone has tampered with my app, so it's not legit anymore. And that's how we detect modification. And then SSL Pinning. That's what we're going to discuss next, and that's why I left it hanging there, and I'll explain what it is in a minute. So next, SSL Communications. So we have 2 kinds of encryption, symmetrical and asymmetrical. Symmetrical, the well-known one where I encrypt and give you a key, and you with that same key can decipher my message. You can decrypt it. But there's another kind of encryption where I say that I use this key as encryption, but you can only decrypt it with another key, not the same one as for encryption. So that's a private key and public key concept, right? This is Anna and Bob. Typical example, both have a private and public key. And if I want to send a message from Anne to Bob, Anna can sign with their private key and Bob can decrypt it with a public key, but never with his private key. And just the other way around. if I'm using the public key, you can only decrypt it with Anna's private key. That's why it is asymmetrical. So we've shared previously, priorly, the keys. Asymmetrical encryption is what's used by servers nowadays that we find on the web or our browsers. So we have HTTP and HTTPS, which is the secure protocol. What's the difference here? If it is HTTPS, the server is giving me its public key so that my communication is encrypted and then decrypted on the server with the private key. So far, supposedly, so good. It seems communication goes through a secure channel. I can never break up that encryption because if it moves from my computer to the server has a private key. I don't have it, so I cannot read the message. You also need to take into account, and is kind of a security recommendation for a browser, a website, let's say. You see the green lock means it is secure. So the certificate given by the server is secure. If I see an I, it means that is uncertified, which is usually HTTP. And if it's crushed or red or a non-secure symbol, it means there is some problem with the certificate. Either it's been replaced with one that is not valid anymore, or else it's expired. And certificate example that is easily used is Let's Encrypt. Now we move on to bypassing SSL. So there are two different kinds of communications on web servers. Data that are encrypted and those that are not encrypted because they are transferred through HTTP. If it's SSL communication, I cannot see the information. I've just explained that. But it is not totally true, and I'm about to explain it. So if I open my browser and I use Wireshark as an interception, Wireshark checks the traffic on my computer to see the data on my network. So I have Wireshark here, and we see there's nothing to be seen. Because that's a secure channel. But we can run a SSL bypass, and that's the idea of skipping it. So what is this? I have the server and I have the app, whether it is web or mobile. Server sends the public key and the certificate for the encryption. What if they stay in the middle? So I run a man in the middle, right in the middle of the communication, that is, and I get the certificate. I encrypt it myself, and then to the user or the client I send another certificate. In the end, that communication always follows our encrypted channel, but in between, I'm breaking it up. From the server to me, there is a certificate. I get that information, I decrypt it, and then, following another certificate, which is one I have, but not the regular one, I send the information back to the third party. So, tools that we have. Subproxy, Charles Proxy, and Burglar Suite. You can use them. We'll see how you break up that communication. So, as I was saying, I've started my proxy here. using Bear. This is Bear. And the only thing I have to say is go to the proxy tab, and in options I click, I want to start a proxy port 8080, and I would say for the whole interface, the network interface on my device, I have the proxy on the 8080 port or a given address, IP, whatever, you start your proxy, which is an 8080 proxy. So I've started it there. It is running already, and you can see it here. So we have the browser settings here, then proxy, and there, this proxy will run on port 8080. That's the local address, right? And that's where the proxy is. If I say use burp, that's where the communication is. So yes, communication is running through the proxy, but I don't have the certificate to break down the communication. Here you see on burp, I can set up the certificate. You install it, you store it, you save it, and then on your settings for the browser, security, certificate, and we can import it. And already imported this one. So this one has been imported, the certificate, which means that from the server to my proxy, and from my proxy to the website with another certificate, right? So green lock here. It is secure, and this is not the certificate I wanted, it's the one that I've installed myself. So this is the AS journal. It's the AS newspaper, that's the name of the newspaper, so I can see everything crystal clear. That's an SSL bypass. We are bypassing the encrypted communication. That's what we are breaking up with. So moving on. What about mobile or smartphones? Just the same as with websites. Just the same concept. An SSL bypass, web or mobile, is just the same. We just need to set up the proxy for our mobile phone, for our smartphone. So, you get the certificate, set it up on your device, and through a proxy it goes. I'll be using the app for the University of Seville to run my bypass on Android. This is my virtual machine. Problem starting. So this is an Android emulator that there is a free of charge version that you can download and play with it. this is one of Android's emulators, as I said, and I'll show how you set up the certificate, same as with the web, but for Android. There it is. First of all, see where I am. So am I logged onto this Wi-Fi? Since I am, it works. I've been pressing it for a while to see if it works. So I have to say, change the network. And so I have to say this goes through my IP address, the one for my proxy machine. (192.103). Again, port is 8080. I save it. And there you see the proxy. And I set up a proxy, go lead into this IP address and the port 8080. And so my smartphone communications are channeled through what I've just started or just put live. And once this is done, I need to install the certificate. And how do I do so? Same as before. Here, http :/burp. For new Android versions, 7 and onwards, I can just push this button here and it set it up for me. This is previous version, this is number 6. And the only thing we need to do for it to work is we choose settings, input and export certificate, and I export it on P12. Certificate .p12, I add a password, I download it and install it on my cell phone. And so I can have it on my device. How can I have it on the cell phone? Well, we need to, again, choose settings. And then security. So this is credentials, and that's where I say the certificate. You see it there? I click, and I want it on my device. So here, same as before. So same for the cell phone as with the web. And if I'm in there, if I get in there, which is the AS newspaper website. And same here with the University Seville's website. Check this out. Here you see the user name and the password. There's a man-in-the-middle attack, and this that was encrypted, I've broken it, and I conducted, I've run an SSL bypass. So just one proxy, a certificate, that's all it taken. And then for iOS devices, just the same. Exactly the same. I need to set up the proxy for the phone. So it is off. I turn it on manually. I state IP address and port, same with the certificate, HTTP :/burp, and I set it up just the same. Settings and everything. And just like that, on Android and on iOS, we've broken the communications. We've broken them up. So what about Twitter or any other app? We can test it and see that on the alert tag for burp, you get this message. Well, the SSL has failed, and so we cannot log. We did not manage to break that chain up. And so further, later, we will explain why and how we can keep it up. But before that, let me say, because this happened to me back in the day with Android versions, actually, well, let me explain what happened to me. Did same thing I've just done, but there came a point or a time where the proxy was empty. Nothing was going on. Nothing going through the proxy. And this is all very weird. This is all wrong. So I started checking what I've seen now. So device certificate burp was on, proxy setup was right, making sure the certificate is a valid one. It was all right, or so it seemed. But what was happening? So I looked into it, and I realized that Android version from number 7.0 onwards, these network setup changes, recommendations change, and now it is done differently. So Android from this version onwards has released a method to set up the network security. So what does it do? On the Android manifest file, sorry about that, my phone's ringing. On the Android manifest file, they've had the security setup, which is an XML file where I specify what's the security setup for my app or what the certificate is. So on Android manifest, which is an XML file for every Android app where I state the permits, the main purpose and everything is stated there. I also state the security setup. So we've said that you need to state the network security config as a file, an XML folder. There is a network security file, config file. What's the structure? Whatever tags are needed, and so we say for this domain, I need this certificate. That's the one that validates what I want. And with that, if I try to conduct an SSL bypass, since there is no certificate checking it out, it doesn't work. But going deeper, I realized this file where you need to specify that you've got the URL and you need to import the CA you want to use, well, it is a pain because there I need to produce another app so that I can reuse it again. So I found this method. I came up with this method, the same file, but instead of saying this is the URL, this is the domain, and this is the certificate, what about using the systems and the users? So if we add this setup to the app, it works just the same as we've done so far. Let me show you a short demo on how this can be run. We'll be using APK tool. So you send the APK file as used on Android, and APK tool decompiles it into an intermediate code, which is not Java or assembler. It is a code of its own. And we will get the Android manifest at the file and decompile it. Can you see this? Better now, right? So here I have APK tool, which is a tool. Easy peasy. First one is decode, to decompile, and second one is build, to build what's on our APK. So we use APK tool, D for decompiling. This is the virtual secretariat app for the university. And so the demo runs, it decompiles it all. And that's a folder. Cybercamp, CViews, demo. So this is a structure, a folder structure, where I have my Android manifest, the file we'll be using, and in here we need to find an XML folder. If it's not, we will make it. But we should have one here. If not, we just make it ourselves. That's what we have to do. Android manifest first. Open it. And where it says application, Android, column, network, security, config, equal, at, XML, slash, network, security, config, dot data, no need for dot XML. So we've added that feature to the Android manifest, so I save it. And here you have it. Up and ready. I have this little folder. And here you see there's nothing about it. Same folder, file rather, where I state what the user certificates to be used are. I have to copy it first and take it here to the network folder. If there's not such a folder, I just open one, create one.
Demo 3, ¿vale? Made XML, y ahora digo que
XML and then copy network security config XML.
config.xml. ¿Vale? Con lo cual me la ha copiado.
It is copied, and now back again where I have my demo folder. I've changed that. I changed the Android manifest and I've added the folder and I recompile it again. I state what the folder is and I say this is cvs.modified.apk. Alright, once again, I compile it all in order to use this app. Same as with the SSL Bypass, but instead using this method. So we have the app, we just set it up on our device and it is ready. Next. On iOS, with the new version, something similar happens, where we need to go into general part of side of information. So there is this setting that says produce information. We push it, and we need to validate the certificate. Otherwise, it's off. It's happened that to me that I got the certificate, same as with any other case. It was working. And so why is it not working now? Because there was a double factor, so you need to go into produce information and confidence setting, and CA needs to be on for it to work. So I just wanted to say that SSL Bypass comes with this problem in recent versions, but next, the larger problem many people have when working in auditing of mobile apps, and as we've seen on Twitter, there is these fail. So there's a failure in the communication, so SSL fails. And why is that? Because we implement SSL Pinning. Same as before with the SSL Bypass. And as I was saying, what if the app or the web queries, sends a query about what's this certificate you're giving me? That way I can say whether it's legit or not. I can say the certificate you're giving me, I have stored it with a hash code and I check whether it is valid or not. That's SSL Pinning. It is just checking the hash code for the certificate. That's it. Start the HTTP communication, a certificate is granted, and then the app says, all right, but before using it, I'll try and see what certificates I've stored or saved, and let's see if they are the same or not. If it's the same, I keep on with the communication. If not, I halt it. I halt the communication. That's what SSL Pinning is all about. And that's what happened with Twitter. Because it implements SSL Pinning. We cannot bypass SSL as we've done before. We need to go a bit further. So what about SSL Pinning? What do we do? It's masked, there's nothing we can do? Well, that's not it. We'll see in a minute that there are other measures on how to break the SSL Pinning, if it's poorly implemented or in a different way. So, first example here, which is an SSL bypass for SSL Pinning with a root on the device. So if I have a root access on a device, I can follow some techniques in order to break the communication. What do I need to do? Making sure that the certificate is not checked, or the certificate that is indeed checked is the one I want, the fake. There's several ways around it. First one, tools. There are automated tools to deactivate SSL Pinning, but you need root access or a jailbreak into the device. So let me explain what these tools are. I think that's what people enjoy the most, because it is a big button tool. Easy, because it is installed on your device, you push the button and the problem is solved. That's why on Android we have SSL Unpinning. We can have so many more, but this is the most used and the best known one. But before using this tool, we need to have, which is this what we have, Super SU. If we want to have that on our Android device, we need to see how to install Super SU on our Android device, so that we have different modules. Every mobile is different when you are about to set it up. So you need to have root access. You can use this Super SU, and once you have it, we need to install the exposed framework. So what we need to do is simple framework, install and update, and that's it. So we find the SSL Unpinning, we push the button here, you install it, you restart the cell phone, and it's already ready. So we can follow the same technique as with SSL Bypass, but bypassing measures that we had. The emulator that I have, well, you cannot install it there. You need to have a physical device, because this has only been done for ARM. And if you didn't know that, let me tell you that usually they have an underlying IRM infrastructure, and this app is only been done for IRM infrastructures. So my emulator is running on Intel, and so it doesn't work. It says that architecture is incompatible. So it doesn't work. Then iOS. We have Ssl Killswitch 2. Simple tool. You know Cydia? So Cydia, when jailbreaking, jailbreaking means that you install Cydia, which is a repository, and you need to install the right repository to have the SSL Killswitch installed. If you look it up on the internet, you have the great manual to see how it is done. But I found it on Cydia's repository. So only thing you have to do is jailbreak it, restart the device, and it's already there. So just like this, we've also bypassed the SSL bypass.
Aquí tengo una demo para que lo veáis ahora.
I brought a demo for you to see how it works. If it works, if it connects with the phone.
Un momento. Vale. Y ahora... Un momento para que lo veáis todo, ¿vale?
I just want you to see how it works. It's connecting now. Well, this is my iOS phone. And I couldn't show you earlier because it wasn't online. So, I'm logged onto the Wi-Fi now. Can you see? I don't know if I can make the letter size any bigger.
Ahí un poquito mejor, ¿no? Vaya, hombre. Bueno. Ahora no se quiere conectar, ¿vale? Bueno, no sé si, lo siento, pero ahora no se conecta, ¿vale? Lo único que tenemos que hacer...
Apologies, but the connection doesn't seem to be working. But anyway, let me just show you how it works here on my mobile phone. This is Wi-Fi configuration here. We need to tell the system that it has to go through a proxy, which is manual. We need to tell the system. Right, that's it. I say manual proxy. And here we need to type the IP address. I need to tell the system go through 104201 and the port is 80. 8080. So that's that done. And now I go to http://pool. I don't know if you can see anything from that distance, but this is where you can install the certificate. It asks you, do you allow it? Yeah, and I say yes. We need to type in the code, and then we press to install. That's verification done. And now, for the second step, I need to go to the general area here. I go to information, and right at the end it says settings or adjustments for system security. Well, I need to accept that because otherwise it won't be installed properly. That's the certificate installed, and this is the Ssl Killswitch. It says it's been installed. I have installed the application correctly. And then any application, even Apple Communications, will work, you see? Well, any application I use, for instance, eBay. Well, look at that long list of applications that are working, including Google as well. It's just one single tool to break that. It's ever so simple, right? You can understand that this is a tool which is good for SSL pinning breaking, like Trustkey. Tools that I use to implement SSL pinning tools. Now let's continue with the next section of my presentation. Well, we said there are different tools for SSL pinning, bypass, and then we need to see if those tools are common, if they can be jailbroken, because otherwise they might not work. This is I call it a fat button tool. But sometimes the application then crashes, it can't be installed. We can encounter different problems, or maybe the device we're using cannot be rooted because it's proprietary. For whatever reason, we can't do it on that particular device, or maybe there is a control on that app to detect rooting or jailbreaking on that device. And in that case, this solution will not work. Right, so what other possibilities do we have? This is the next process. It would be modifying the app. Just like we use the APK tool or Hooper, there are different ways, different tools. Well, the way to do it would be modifying the app, checking the different process for SSL pinning to be done, and also modifying the certificate or the signature. Well, here we see the steps. First, creating a store for empty keys. Well, you can see the different steps that we're going to be covering and running through now. This is where we can see that in this particular application there was local task manager factory. That's where we can modify things and change the certificate so that we can have our certificate. And just by compiling that application, you don't need any more tools. It would just work. But logically, if we touch the source code on Android or iOS for that application, then that's going to fail. If we need to modify the source code for one reason or another, we'll end up in the application closing. It's not a good method at the end of the day. Most of the time is just cumbersome for what it does. But look at this quote up on the screen. A bad method is better than having no method at all, right? So when we talk about modifying the app, well, it would be my last resort. If I had no other way to do it, then I would go about it that way. But fortunately, we have more methods to resort to. For instance, let me just start with an explanation of what hooking is. And then we'll continue with the pinning, SSL pinning. What is hooking then? A hook, well, it reminds me of Captain Hook and Peter Pan. It means that we hook up to a process that's running on the memory. Hooking means debugging a function, but dynamically so. That is, a function that's running on the memory dynamically, not with static code. We would be modifying it dynamically then so that the outcomes are what we need. Here we see the diagram, a process that goes through a function, and it gives me an outcome. But the second possibility, through hooking, instead of going through the normal function, it will go through a different function I set. That happens dynamically on the memory, and then the outcome will be different. How can we go about hooking? It sounds more complex than it is, actually, because we now have tools that allow to hook on to processes in a very simple manner. One of the tools is Frida, a hooking tool where as the process is running on the memory through JavaScript code, which is simple, then I say, hey, this function that's running on this device, instead of saying true, it should say false, or it should say null. And thanks to that, the process modifies the app. So this is one of the possible tools, Frida, which we'll be using. I would now like to show you a case for you to see how to skip the routing detection on an Android device, because there's a function that says, hey, this mobile phone has been routed, is routed. Well, I tell the function to say false, for instance, or say null, and then it would skip that part. In the case, if we use Frida, before we use it, we need to provide a file in JavaScript with a particular structure. Well, this is one possible structure, but there are many different sites where you can find files like this with different examples. But basically, when we click, we need to say, when there's a main activity, instead of doing A, then do B. Let's see how it works on this video. When I'm going to click on the function, what would happen normally is that the application would close, right? But look what happens now. I'm calling on Frida. I provide it with a JavaScript file and the parameters of the process. You see how Frida gets on with it. And the time comes when it says the onClip has been modified. Well, once that modification has been done, I press OK, and that's how it skipped it. The application has been modified, and that's done not on the static code, but dynamically through JavaScript. I've said if this happens, then this should be the outcome. That's the idea for hooking, right? Modifying a function so that the final outcome is different. Let's continue now and see how we could do the same thing to skip SSL pinning, because we want to skip the checking of the certificate, right? That's the idea. So the hooking tool, instead of checking it, it would skip it. For a mobile phone without routing or jailbreak, I think this is the best way to do the bypass. How can we go about it? First, decompiling the app to add a Frida framework, so that instead of giving it the JavaScript, Frida will provide us with a file that can be embedded in the application. Just like we did with the APK tool of decompiling, then compiling, same thing, but providing the Frida library, so that when the application starts to run, that functionality will work without any problem. That's the idea. Decompiling the app, adding the Frida framework cache, and then some other functions. All of that is then compiled again on the app, and then it works on gadget mode. Let's run the demo for you to see, just for you to see how simple it is. Because fortunately, we have a tool called Objection. Objection runs on Frida as well. It uses Frida. And thanks to that, I can patch, I can do all these things that we are going through, but automatically. Patching APK. That's what I say. Oh dear, I forgot to connect it up to my mobile phone. That's quite basic.
Un momento. Vale, ahora sí me ha salido ahí, ¿vale? Entonces, bueno, como comentaba antes, ¿vale? Ahora...
Here we have it. It detected the architecture of my mobile phone, and just through USB, it finds that and downloads the gadget from Frida, from the internet, and then it just patches the app. It's simple, isn't it? Just one single function to modify and compile, and instead of going through all the motions, it does it just very simply, automatically, and for the application serious.objection.apk, as you can see up on the screen. Now I need to say install. I don't know if it's been installed already. Oh, yeah, it says something's wrong because I have it installed already. I then start the application. And now all we need to say is objection, exploit. Just look at it. What's happened? It connected to the process through objection on my mobile phone, and I can then do anything, give it a file, whatever. And then why is objection so useful in this particular case? Well, because I say Android SSL Pinning here. Disable. I have deactivated, like that, the task manager checking and all of that with objections through hooking and on a mobile phone without routing, without any problems. It's simple. See how powerful objection is. And what can I do now? All sorts of things. Android, hooking, list, anything. Activities, method types, all sorts. We are skipping the checking of applications like that on Android, just with one single line of code. You see, we've already seen 3 different methods to overcome that problem on Android. Let's continue now with the presentation. Because it's not just Android, we also have iOS, and that's a bit harder to do. If we don't have jailbreak on iPhone, then because it's a closed system, it makes our life harder. But it can still be done. Not as easily as on Android. It's a little bit harder. For instance, we can get the like for the APK file, but for iOS, for instance, we can use the class 2 tool that does a dumping of the file and converts it into an iPad file. Or we can find on the internet one of those applications that can do it. So if we have a phone with jailbreak, it's easier. Otherwise, we can get it on the internet. Well, this is like we used to do with APK. The next step would be modifying it. On Android, you can modify an application, install it, and it still works fine. Why? Because Android doesn't super check developers and signatures and so on, whereas iOS makes things harder. We need to set up a a developer profile. We need a Macintosh system with everything set up so we can create a developer profile. Well, on the Accounts tab, we create a profile, and there we create an iOS certificate, profile certificate. Once we do that, we run this command we can see up on the screen. And look at that code, double O, whatever. A code which is like the core of our signature. That's what Apple then checks to see that we are the developer, and so we can continue to work. Once we have that code, we go to objection, and we would do exactly the same as earlier, but with patch IPA, plus the code that we got here, right? Right, that's done. I then sign IPA, modify it, and so on. So for us to use objections, we need to use a Macintosh system here, because we need certain Xcode tools for it all to work. Right, let's just see an example for you to get an idea of how it works.
Se ha quedado pillado. No.
Oh dear, it's a little bit stuck.
A ver si restaurándolo un momento.
Let's restore and refresh.
Muerto. Bueno. Lo voy a apagar.
Well, it's definitely stuck, so I'm going to stop it and start it again. It's going to take a little while, so let's keep going. So that's one way to go about it, or I could also use the open tool. That means that I would provide the binary code of IPA, because IPA is like a .zip file that can be open, and then get the binary code, and with open tool inserting SH. That's one other possibility, but the easiest way is using Xcode and objection to compile the app. So for that installation to work, I need to use a tool, which I find here, Mobile Tools Impactor. Are you familiar with this? Are you familiar with Impactor? It's a tool where I go here, I say install, and then I need to tell the system that IPA is fine. I then give the system my credentials, and I can then sign on the device. And then once we've overcome that barrier, then the rest of the process is just like we saw earlier. Let's see if that's working now. Oh dear. I'm going to close it again. It's stuck once again. Right, look at that. The app is running on my iPhone. And the hooking from there is like for Android. If I want to skip SSL pinning, what do I do now? iOS, SSL pinning here, and disable. Enter. And then it does its own thing and disables it. Or deactivates it. Well, and then we would continue like we saw earlier, getting the Xcode. Oh dear, it's telling me now to update it. But anyhow, I would get the Xcode and then run objection. Then objection patch IPA. Patching, just like we saw earlier with Xcode, I would patch it and then install it on the iPhone. So objection explorer would be on Explorer. The system would understand the gadget is working and it would hook. And the same thing again, jailbreak. Here is where we can erase the detection for jailbreak. And all of that without jailbreak would work exactly the same. Just like we've seen now with jailbreak.
Vale, esta es la demo que hemos hecho ahora, ¿no?
This is our demo with Frida on iOS. So then, all of this that I've explained, SSL Pinning, Ssl Bypassing. I really like playing around with IoT devices, lamps and sockets and everything. And this concept can be used for any device. If I want to tap onto the communications of any device, it can be done. So I thought of auditing a smart bulb that had Wi-Fi connection. So this is my flow chart, right? So this is my app, my mobile app, the bulb, both on my router and then on the cloud, and that way I would know whether it was on or off. So first time you turn it on, and there was something funny about it. I was supposed to go onto an open Wi-Fi, so no security on an open Wi-Fi network. And then I should send my Wi-Fi credentials. Of course, I didn't. I opened another spot with some passwords and credentials, and that's what I sent to the bulb. Once it's been set up, all communication are through HTTP. And everything would go on the router and up on the cloud. From the app to the router, we know how we can bypass SL, right? What about, well, certificate bypassing or SSL pinning that you can escape? But here, I had a problem with the bulb. How do I set up a certificate on a bulb. Complicated, isn't it? Damn it, I have a problem. Either I open it up and ruin it in order to install it, or I need to find a way around it. And as usual, a man in the middle. A man in the middle. To find out what's going on there, you need to be in the middle of the communication. So I went deeper and deeper and found a tool, SSL Split. SSL Split, from my device to the server, is HTTPS, but if the client allows so, it'll be HTTP. So it is not encrypted. So SSL Split is splitting it. So I get the HTTPS, and if the client allows for it, I can have an HTTP communication, so I can split it. That's where I could see the communications for the bulb. With that idea in mind, same as with phones, iOS, Android and everything else, just the same can be used for any other device. So if we have a clear mind and we know that I have an SSL communication, I have the server, I know who the client is, with the tools that I have, and I need to see how I can break it. Cannot have a clear method because there are many examples and many connection methods. There are many kinds of bulbs. It's not just Wi-Fi connected, but next to the infrared device and then something else. But in the end, the underlying idea is just the same. An SSL communication channel, a certificate in between. I need to have something in the middle to break it up. This is the practical side of the workshop, and so I like to draw some conclusions before we leave. I was talking to a colleague in the morning. So Paco, you explained everything that can be broken, right? But if I'm a developer, so how can I sort it out? This is a problem, isn't it? Because I came in here and I destroyed everything, right? But I did because people don't take the necessary measures. And if we did, maybe we could sort it out. Some clients asked, okay, you've bypassed SSL Pinning, right? But then I need to talk to the head of the development and explain how to solve it. So it's not about the framework here. It's not something that I set up and I say, okay, sort it out. Fixed it. It cannot be fixed like that. Problem is, how do I fix it? Every app have control methods and they can all be split. But it's not the same using a fence as on the left side or the one on the right side, that is the Chinese wall. Because if I use a barbed wire, in 5 minutes they've cut it out. But with a wall, it takes them 2 weeks and maybe they give up. What do we need to do? And I've said this before. So 5 types of control that I think are very much important. And if we follow all 5 of them, our application security will increase by X%. I cannot really tell what the X means, but you yourselves, by checking the controls, you can understand why. If we do not use SSL Pinning as we know it, someone by bypassing SSL can see our communication. There's no need for anything else for them, right? But then if we use SSL Pinning, we've seen that it can be split. And then if we have a cell phone that is rooted or jailbreak on it, easier. Because with just a button app, we can split it. So it would be easy to have a root detection as well, so that when the app goes on working, it says it's been rooted. This cannot work or should not be working. Then, if I cannot modify the code, same as before, if I have a device that is rooted, so I cannot run the app as I thought. So I have SSL Pinning, and they have a rooted cell phone. But still, we've seen ways to do it without root. What if I add a control where you cannot modify this app? So I check the signature. So maybe, that's even worse, isn't it? Alright, but still, that control through reversing, we can find the code and I can skip it again. But that's why we have code obfuscation, right? If we have it, they will open our app, they'll see our source code, and they don't know what it is. And it will take them 2 months, 3 months to find them. So, and no one spends so much time on that, or else they have lots of time. And then debugging. It is true that we've got the USB connection. If I lock it out, the debugging will not work either, right? So you see, this is not just one, it's the whole of it. The whole of security. That's why all 5 controls I find are important. Because before that, well, everything is okay. It's we're split and broken, but if we don't do it right, from the basis, from the beginning, we're in trouble, right? So we can have an SSL pinning bypass, we can broken API, so on and so forth. And this has been my workshop, and happy to take questions if there are any. Now is the time.
Micro. Right.
Microphone, please.
Ahí está.
Hola. Hola, buenas.
Hello, good afternoon. Can we also see encrypted communications on WhatsApp?
Y también, si es obligatorio que se debe cerrar una sesión cuando tenemos una aplicación.
Do we need to log out in order to go back and see the user and name and the password? So I only got your first question. I'm sorry, you'll have to ask me the second question again. And so first question, WhatsApp. I don't know about WhatsApp because I haven't checked it, but so I have SSL pinning measures, and underline that there is another degree of encryption. So it's a double encryption. That's, well, I'm not sure, but that's what WhatsApp says, the private key things that you have. So I might see that you are communicating on WhatsApp, but I cannot see what you're sending. WhatsApp is not using SSL pinning, I'm being told, but with an SSL bypass, I don't think you will see it because it's an end-to-end encryption. And then session, you asked? Yes, for you to see the user, it would need to log back. Sure. devices set up at home, such as the bulb or the fridge or the microwave. Amazon had an IoT microwave released just recently, so you're an expert in security and you see the poor practices that so many manufacturers follow. So what about this deployment? What I see is, well, in the end, this is changing. Almost everyone in the end has devices at home. Actually, I really enjoy everything, sockets and everything. But I also like security at home, right? So it's all about paying attention and being interested in what manufacturers do. So they need to have some minimal goals, right? Such as following. No one else knows what's at my place, if it's on or off. That way they won't know whether I'm home or not. In the end, what I've just said, it's only applicable for IoT. Well, not really. Also for SSL Pinning and everything else. Whether they're using it or not, that's up to the manufacturer. There needs to be an audit or someone, and in the end, there will be an attack and they have to reply. And so it follows this. In your experience, does it work with bank apps? So you need to add your username and password every time, whether it is BBVA or Santander Bank. In your experience, can you get the key or have the user and key? It depends, because as the colleague was saying, bank accounts or apps have a double-factor encryption, so an SSL pinning or an Ssl bypass is doable. So I add an extra level of security, and what I do is I send it encrypted. I encrypt it on my cell phone, on my app, and then decrypt them on the server side, which is something to be considered of all the controls that I've mentioned. If I'm decrypting on the cell phone, if I manage to see what part of the code has been encrypted, that's why code obfuscation is important. Because if I see where in the code it is encrypted and I can split it, it is pointless, right? Back there was a question. I have a couple of questions, if I'm allowed. First one, once we've done the SSL bypass with JavaScript, can we? Sorry. Once again. Does it work now? No, it does not. So text. Can you read it on JavaScript? Yes. With Frida, what I've explained is any feature can be modified for it to do whatever you want. If you want to have a record or a log, you can change it so that everything that you write is recorded. You can change it. And then, if you want to see something else, you can get also a logcat. So same as I said with the USB. But you use logcat, and everything done by the device is registered. And you can see that. Second question. Once you've opened the SSL connection and you've edited it, you can send to the device a function or feature that would have Sorry about that. Access to the memory, where it would read any other information for any other program that can be whatever. It depends. Usually it runs on a sandbox. So depending on the permits, you can have access outside or inside the sandbox. If routed, you might not have access, but only permission to have access to your sandbox. But if rooted, you can have, instead of a file, have something else that is part of the device. So that was Meltdown and Spectre's vulnerability, right? Yeah, more or less. No more questions on my side, thank you. There's one more here. So you have your cell phone and your PC connected to skip the route. Do you need to do it every time, or well, that's dynamic. There are two kinds that I've explained. You can change the app, not advisable because you're changing the static code of the app, and once you change it, you set it up, and this will never be requested again because this is part of the code that has been changed. But then dynamically, what you're changing is memory as well, as if it were a computer. When you run an app, all the code goes onto the memory. So if you change it on memory and turn it off, it all is erased, and then you reload the code that you had, static what I had. Do you check it? Yes, then it will be again. Anyway, apart from skipping the root, to skip the fingerprint verification in any app? Yes, it's just the same. You need to see where in the code the check-in is, so that you can skip it, so that it always tests positive. Yes, it's all about skipping it. Saying, as credentials, I want your fingerprint. So, haven't skipped it, but maybe it doesn't make any sense because the fingerprint is used for Apple to give you credentials to log somewhere, right? So I understand. If you skip that, there's no credential. But instead of skipping it, can you not make sure that the app thinks it's tested positive and it is you? No, because it's on Apple. And Apple has all the securities it needs for the fingerprint and credentials. You need to skip it so that it's not requested. But if not requested, no session started and it makes no sense. There's no point in it. Thank you. If you were in our shoes, but if you were a student, very much interested in cybersecurity, so I'm working on web development, or rather studying web development, and I'd like to know about cybersecurity practices. Where would you start? If you like development for web and mobile, owasp is a good starting point to start reading it and see every control that can be used for a web. So I develop it, and these controls, which ones do I follow, which ones do I not? You will see that even if you're into security and you do things right, over 50% of the cases are not explained because it's unknown, it's underexplained. So I feel for everyone, well, you and those on streaming for mobiles and web, it is important to read OWASP guidelines, one of the most abundantly used, and see the requirements they are requesting, which are the minimum requirements, if you ask me. It has to do with web development as I'm studying, but you work as a pen tester, right? If I were interested in security as such, in the end it's just the same. In order for attending pen testing, you can use owasp guidelines as well. So you can attack and defend. And probably, if I have to audit an app, I don't know it by heart, the guidelines, but I know what is done run in order to test that. One thing or the other, both. What matters is knowing the not so strong suits of a given application.
Hola, buenas.
Buenas.
Un siguiente.
Let's focus on forensics for case resolution and investigation. It's used for attacking, right? But as a forensic analyst, how can I detect that I've been attacked? That my system's been attacked? Good question. All right. You need to consider this way. Well, first off, the app on the device might not be legitimate. So that could be one example of an attack or a breach. If I manage to find an app on my device where the signature is not the original signature, I know it is not legitimate. And what's difficult here is, since I am modifying on the code of memory, if I don't turn it off, I might see that it's been changed, but if I turn my phone off, it's gone, it's lost, so it's complicated. Only thing I can do is check in the signature in the app and see whether it's been breached. But since if you're touching it dynamically, if it goes off, everything is gone, right? The API keys for Google services, can they be masked? Can they be obfuscated? Well, I think there are ways not to go through the API key directly, if I'm not mistaken. Not sure, but I think in the end, you have a token, and I think you can have random tokens that can be used as API keys. Because if you see the API key on the app, the service could be used at will. But there are ways not to use it and only use it in a mask way. Or as said by the colleagues, you don't want to send it, just encrypt it. Apart from SSL, send it encrypted as well. So if they combine the app, yes, of course, they can use code obfuscation. So the API key is not enough. Well, actually, I have this feature, which is ABC. I have different letters. I don't know what it means. I don't know how it is being encrypted. So you need to play around with it. But it would extend the process, right? And so, well, it would take lots of time. Masking would take us lots of time, but if you see that a feature or a function is ABC, A it means whatever, and B means whatever plus 1, and there is no relationship, but there are many classes there, and in many classes the name is A, so the name is just the same. I don't know which one's which. It's a bit confusing. I've tried it, and it's a bit messy. All right. Okay, thank you, everyone.